Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on Coulomb's law of magnetic force and Gauss law. In this case, Coulomb law states that force between two magnetic poles at a certain distance apart is directly proportional to product of pole strengths and inversely proportional to square of distance between the poles. In electrostatics, the force was directly proportional to product of charges. In place of charges, here will be pole strengths. And in that case also, it was inversely proportional to square of distance between charges. But now it is inversely proportional to square of distance between two poles. So if I take M1, M2 as pole strength, then this force is mu naught by 4 pi M1 into M2 upon R square. Here mu naught is known as absolute permeability of free space or air. Now, in this relation, this constant mu naught by 4 pi has value 10 raised to power minus 7 Weber per ampere per meter. Now, if we talk about magnetic dipole moment, in case of current loop, this is given by product of number of loops, current and area of each loop. So, this is the magnetic dipole moment in case of current loop. But in case of bar magnet, it is pole strength multiplied by distance between two poles. In case of bar magnet, actually what happens, pole strength is same. M1 equal to M2, let it is M. And 2A is dipole length or magnetic length. So, dipole moment was small m into 2A. If I compare these two equations, then NIA equal to M into 2A. Now in this, capital A denotes area of the loop. 2A denotes distance between two poles of the bar magnet. From this, we can find expression for pole strength. It is N into I into A upon 2A. If I put the units in SI system, number is having no unit, current is having unit ampere, area meter square, 2A is distance meter. So SI unit of pole strength comes out to be ampere meter. So SI unit of pole strength is ampere meter. And in case of dipole moment, when we talk about current loop, it was found to be NIA. So when I put SI unit, current is having ampere and area is having ampere meter square. So dipole moment has SI unit ampere meter square, but pole strength has unit SI ampere meter. We can also define this ampere meter. I have this relation, Coulomb law, in case of magnetic poles. If these two poles are of equal strength, let it to be 1 ampere meter, and R is distance between two poles, let it be 1 meter. Then what we find, this F comes out to be 10 raised to power minus 7 Newton. So we can define pole strength, SI unit of pole strength, that the pole strength is said to be 1 ampere meter if it repels equal and similar pole with the force of 10 raised to power minus 7 Newton when placed 1 meter away from it in air or vacuum. And Gauss law is magnetic flux through a closed surface is 0. In case of electrostatic, electric flux was Q by epsilon naught, but here magnetic flux is 0. Or you can say surface integral of magnetic field through a closed surface is 0. It represents that isolated magnetic pole or monopole does not exist. If I want to separate North Pole from South Pole, if I cut the North Pole, automatically on lower path will be South Pole. So monopole does not exist. B dot ds surface integral over the closed surface is equal to 0. This also suggests that number of magnetic field lines entering closed surface equals to the number of field lines leaving the closed surface. So there is no source or sink of a magnetic field in magnetism. Thanks for watching this video. Like, share, subscribe my channel.